Hello everyone, how's it going? My name is Dan the Tutor. In today's lesson we're going to be looking at quadratic functions and parabolas. So this is lesson 7 of 8 for the free summer courses. Only 2 more to go, this one and 1 more week, and then we'll be done. In today's video we're talking about quadratic functions. Basically, the last couple weeks we talked about linear functions like y equals mx plus b. Today we're talking about quadratic functions, which are the second most important kind of function to know for Algebra 1. So let's go ahead and dive right into it. So first, I just want to contrast the difference between what we were looking at last week, which is the stuff on the left, and the stuff on the right, which we'll be doing this week. Obviously, you can see the difference is the left side does not have x squared in it, and the right side does have x squared in it. That is the biggest difference between quadratic and linear. So in other words, all of these are linear functions. All of these are going to be quadratic functions. Quadratic simply means it has an x squared in it. So all the 3 on the right will have quadratic forms to them. Now the other thing we need to know is that quadratic functions are in the shape of a parabola. They are in the shape of a parabola, while linear means the graph is in the shape of just a line. Hopefully we all know what a line looks like by now. I don't even know what to say if you don't. But for a parabola, it's probably a lot newer to you. So let's go ahead and talk about what a parabola is. First of all, it looks like this shape right here. This is a very famous shape of a graph. This is the parabola, and it's important to know how we got it by graphing it. So for instance, I have a table of values here. Let's go ahead and fill in -2, -1, 0, +1, and +2 for x, and let's see what I get for the y values. So first I'm going to plug in -2. So y equals -2 squared. And one thing you should absolutely know, when you square a negative number, it becomes positive. When you square a negative number, it becomes positive. The reason for that is simple. Really, -2 squared is the same thing as -2 times -2. And the 2 negatives make a positive. In other words, you're going to get +4 as your result. So that's what I'm going to plug into my y chart. Now if I go down the rest of the list, for instance, -1 squared will become +1. 0 squared is still 0. 1 squared is 1. And 2 squared is 4. And if you were to plot these points, like for instance, -2, 4, then -1, 1, 0, 0, 1, 1, and 2, 4, and then you connect the dots like this, you're going to get the shape of the parabola that you see in front of you. And that's basically all you need to know about the parabola, how to graph it, there you go. But one huge thing that we're going to be spending most of today talking about is A, the vertex, and B, the different ways you can write the equation of a parabola or a quadratic function. So real quick, let's talk about the vertex. The vertex is simply the highest or lowest point in a parabola. And the reason why I have to say highest or lowest is because here, in this example, it's the lowest point. That's where the vertex is. There is no highest point. This graph goes on forever, right? So it only has a lowest point. You're never going to have both for a parabola. You're never going to have a highest and lowest point. You're either going to have one or the other. So there we go. There's the vertex. We see it's at 0, 0. By the way, one thing you ought to know about parabolas is that they can also open downward. As a matter of fact, on the next page, I show you a bunch of different ways that parabolas can look like. All 3 of these graphs. I'm not going to tell you what the graphs are, but as you can see, parabolas come in all shapes and sizes, but all of them have that something like curve, I guess you'd call it. All of them have that curve shape in common. And once again, I would recommend knowing that the vertex here is at 0, 0. The vertex here is at 1, 2, 3, 4. So 0, 4. 4 for the y direction. And then over here, we move the vertex over. That's absolutely okay. The vertex is at 1, 2, 3, 4, 1. And so, of course, you can put the vertex wherever you want. You can have the parabola open upwards or downwards. And there's a bunch of different ways we can write the equation for that. As a matter of fact, here's 3 ways we see before us. Standard form, vertex form, and intercept form. So we're going to start with standard form. Actually, we're going to skip standard form. Even though standard form is the most common you'll ever see in math, I'm actually going to skip it. We're going to start with vertex form because we just were talking about the vertex. So vertex form is good for finding the vertex. Let me explain. When you see a parabola written in this form, so as an example, y equals 2 times x minus 1 squared plus 3, this is an example of vertex form. It makes it very easy to find the vertex. The vertex is always going to be at h comma k. So whatever your h is, that's your x coordinate of the vertex, and whatever your k is after the squared part, that is going to be the value of your y coordinate of your vertex. And one thing you ought to pay attention to, if you notice it's minus h, that means whatever h is, it's the opposite. So in other words, when I see x minus 1 here, I know positive 1 is going to be the vertex. And then plus 3 you don't change. You don't change the plus 3. That's still positive 3. But you change the x value, the h value, instead of negative 1, that would become positive 1. And if it was plus 1, it would become negative 1. Don't worry, we're going to look at a ton of examples of this today. Next, we have intercept form. Intercept form looks like this generally. An example would be y equals, let's say, 3 times x minus 1 times x minus 4, something like this. And this is great for finding your x-intercepts. Maybe you forget what an x-intercept is. I spelt finding wrong. That's funny. Hold on. There we go. Sorry about that. It's good for finding your x-intercepts. Now, what is an x-intercept? An x-intercept is where your graph crosses the x-axis. Let me show you an example. In this example in the middle, the x-intercepts are here and here because that's where it crosses the x-axis. And for the one to the right, there are no x-intercepts, so you couldn't even write it in x-intercept form if you wanted to. That's interesting. So there we go. There's the intercept form. Oh, and by the way, based on this equation, you're going to have x-intercepts at x equals p and x equals q. And look at the equation again. See how it's minus and minus? That means it's the opposite again. So in this example I made up, you have x-intercepts at x equals 1 and x equals 4. Both positive, because again, it's the opposite sign. And now that we've talked about vertex form and intercept form, we're now ready to talk about standard form. And standard form is good for nothing. We hate standard form. It's like the worst. You can't find anything from it on its own. In other words, vertex form, easy to find the vertex. Intercept form, easy to find the x-intercepts. Standard form, you can find, by the way, you can find vertex and x-intercepts with standard form. It's just way harder, and that's why we're going to be spending the majority of the time talking today dealing with standard form because it's the hardest case. But we'll also talk about the other two cases as well. So any questions on anything I said first on this first set of pages? Okay, good. Now let's talk about standard form. So for standard form, first we have to talk about how to find the vertex. Notice the form, by the way. It's ax squared plus bx plus c. If you want to find the vertex, the x vertex is going to be at negative b over 2a. C does not even show up in this equation. Okay? Now if you want to find the y value, you need to plug x into the original function. So in other words, first you use this formula right here to solve for x, and then after you find the x coordinate, you plug x into the original function and solve for y. One more thing we ought to know, the parabola is going to open up, and open up just means it looks like a happy face, a smiley face. If the x squared term, aka the a term, is greater, well, I'm not going to say greater than 0, I'm just going to say positive. That's a much easier way of saying that. Basically, your first term has to be positive. X squared has to be positive. That way it opens up. And obviously, if it's negative, that's how you're going to get opens down. Again, we're going to look at examples of this in a minute. So let's go ahead and do number 1. Find the vertex of the parabolas and state whether they open up or down. Immediately I know it opens up. Why? Because that's positive there. The x squared term is positive. Immediately, I know the parabola is going to open up. Now the vertex is the harder part. That's okay. From this example, I know A is 1, because there's an invisible 1 in front of the x squared. A lot of students like to put a as x squared. Don't do that. Never include the x or the x squared in your a, b, and c. So a is just 1, b is 2, and c is negative 4. Now again, I don't care about c being negative 4, but I'll just write it anyway for good practice. Now if I want to find the x vertex, I'm going to say x equals negative b over 2a, which is negative 2 divided by 2 times 1. You do the math here, you're going to get negative 2 over 2. You're going to get negative 1 for your x vertex. Now how do I find the y vertex? Well, it's simple. Plug in this x value into the original problem. So y equals x squared, which is negative 1 squared, plus 2 times negative 1 minus 4. And now we just got to solve this. Remember, any negative number squared is positive, so it's now positive 1 minus 2 minus 4. 1 minus 2 minus 4, that's going to give us negative 5. And so therefore, I know the vertex is going to be at the point negative 1 for x and negative 5 for y, and that's how I write it as a coordinate point. So there's our answers. Any questions on that first one? Okay, good. Now let's do a few more on this next page. Y equals 3x squared minus 12x plus 9. Again, same idea. I'm going to say the fact that this is positive means that the parabola is going to open up. It's going to look like a happy face. And now if I want to find the vertex, this time a is 3 and b is negative 12. So I'm going to plug in the formula x equals negative b, so now negative 12, that will become positive 12 in a second, divided by 2 times 3. So in other words, double negative on the 12 becomes positive, divided by 2 times 3 is 6. Looks like the x vertex is at 2. And now I just got to plug in 2 into the original function. So y is equal to 3 times 2 squared minus 12 times 2 plus 9. And you can plug this in a calculator. I'm not going to because I'm not going to rely on that as a crutch. I know 2 squared is 4, so it's 3 times 4 minus 12 times 2 is 24, and then plus 9. And I know that 3 times 4 is just 12. So it's really 12 minus 24 plus 9. 12 minus 24 is negative 12. Negative 12 plus 9 is going to be negative 3. So my vertex is going to be at the point 2 comma negative 3. There's my vertex. Any questions on that one? Okay, great. Now for number 3, I'm going to ask you to do it by yourself. And just as a little hint to you, I would remind you that there is an invisible, like 1 right here for your A term, and C here is 0, not that it matters. So go ahead, try it on your own, pause the video if you're watching online, and then unpause it when you're ready to see it. Okay, I'm going to say time's up. The very first thing I would say is this parabola is going to be negative out in front for the x squared, which means it's going to open down. It's going to look like a frowny face. That's the first thing I want to say. Next, if I want to find the vertex, A is negative 1, B is 6. So that means the x vertex is x equals negative b, negative 6, over 2 times negative 1. That's going to be negative 6 over negative 2, which is equal to positive 3. So positive 3 is the x vertex. And now I just got to plug that into my original equation. Y equals negative 3 squared plus 6 times 3. Order of operations says to square it first, so 3 squared is 9, and then apply the negative. So it's negative 9 plus 6 times 3 is 18. Looks like the y value is positive 9. That means my vertex is going to be at 3, 9. Hopefully you got that right. And even if you didn't, you have one more chance to redeem yourself. Go ahead and do number 4 on your own. And if you're watching online, pause the video. Okay, I'm going to say time's up. So first, once again, we see that it's negative right there. That means the parabola is going to open down. It's going to look like a frowny face. Next, I say A equals negative 4 and B equals positive 4. So when I say x equals negative b over 2a, it's going to be negative 4 over 2 times negative 4. At this point, you can just say the negative 4's cancel, and you're left with a 1 in the numerator. So your answer is 1/2. X is 1/2. This is going to be annoying to apply into the formula, but that's okay because I don't shy away from a challenge. It's going to be negative 4 times 1/2 squared plus 4 times 1/2 plus 6. First thing I'm going to do is 1/2 squared. Maybe you don't know what 1/2 squared is. I'll tell you it's 1/2 times 1/2. And if you know how to do fractions, that's going to be 1/4. So y equals negative 4 times 1/4 plus 4 times 1/2 is just positive 2. And then plus 6. And I know that negative 4 times 1/4, the 4's cancel. And I'm just going to get negative 1 right there. So negative 1 plus 2 plus 6, y equals 7. My vertex is going to be at the point 1/2, comma 7. And there we go. There's all the vertex problems we have for standard form. Any questions on any of those? So now speaking of the vertex, we now have vertex form. You're going to notice that the problems with vertex form are going to be way easier. We're going to solve them way faster than standard form. So first, just a reminder for the formula. It looks like this, and the vertex is at h comma k, and you have to make the h negative. Okay. The parabola is going to open up again if a is positive, and remember a is the thing out in front, and the parabola is going to open down if a is negative. I don't know why I didn't give you enough space to write that in the space provided, but whatever. So let's go ahead and look at some examples here. Number 1, find the vertex of the parabolas and state whether they open up or down. Once again, there's an invisible 1 out in front of there. That means this is positive. The parabola is going to open up. So immediately I get that answer, just like before. Now for the vertex, well, the vertex is easy. The x value is going to be positive 3, because it's the opposite of negative 3. And the y value is positive 2, because you keep that one the same. So in other words, the vertex is at positive 3, comma 2. Super easy. We're done. No formula needed. Now for the next one, number 2. Y equals negative 1/2 x plus 7 squared minus 1. First thing I'm going to say is that's negative out in front. So that means it's going to open downward. And then for the vertex, again, vertex, super easy. It's just going to be at negative 7, comma, negative 1. Because opposite of positive 7 is negative 7. And then minus 1 will get me that value. So why don't you go ahead and try number 3 on your own now. And just as a hint, you'll notice the k is missing. The plus k is missing. I wonder what you'll think of to do for there. So go ahead, pause the video, and when you're ready to see the solution, you can go ahead and unpause it. Okay, I'm going to tell you time's up. First of all, we notice that 4 is positive, so we know it's going to open upward. That's easy. And now the hint here for the vertex, obviously the vertex for the x value is positive 1, because it's the opposite of negative 1. And maybe you missed this, maybe you thought of it, but technically there's a plus 0 at the end of here. So that means the y value of the vertex is just going to be 0. And there's our answer, vertex at 1, 0. Any questions on any of those? Okay, then great. And now the last form we're going to look at today is called intercept form. Intercept form, again, really good at finding the x-intercepts. We'll look at a few examples below. But the x-intercepts is where the function crosses the x-axis. So for instance, in this graph below, we clearly see that that happens here and here. And that's going to be at positive 1 and positive 5 if you count the grid marks. The reason why that makes sense is because look at the graph I have. Y equals x minus 1 times x minus 5. Immediately I know the x-intercepts are at x equals 1 and x equals 5 because that's the opposite of negative 1 and the opposite of negative 5. So immediately I have the x-intercepts. And like I said before, technically there are graphs out there that don't have any x-intercepts. Take this graph for example. So in other words, when I do have this graph that I drew in the top left, that you cannot write in intercept form. Luckily, we're not going to be doing that today, so don't even worry about that. And now once again, the parabola is going to open up. If you look at the thing out in front, this a, which is always the first term, if a is positive, it's going to open up. And if a is negative, it's going to open down. The same thing as before. One thing I will tell you is that the vertex, if you want to find the vertex now, which we clearly see here, the vertex is at, what is it, 1, 2, 3, comma, 1, 2, 3, 4. The vertex is at 3, negative 4. That's not obvious based on this equation, x minus 1 times x minus 5. So let me tell you how to find the vertex for intercept form. It's not negative b over 2a. That was standard form. To find the vertex for intercept form, all you got to do is take your two x-intercepts, p plus q, and then you're going to divide it by 2. In other words, it's the average between the two numbers. You can also think of it of the point in between the two numbers. So in this example here, the x-intercepts are at 1 and 5. So if I want to find the x vertex, it's 1 plus 5 over 2. 1 plus 5 is 6, and 6 divided by 2 is 3. So in other words, that confirms my x vertex that I said earlier right there. And now if you want to find the y value of the vertex, well, obviously you need to plug x into the original function. So we said x was 3, right? So that means for this one, y equals 3 minus 1 times 3 minus 5. It's going to be 2 times negative 2, and that we get negative 4, which again is what I said for the y vertex anyway. So it looks like this formula is going to work, which is good, because if it didn't, then I don't know what we would do. So now let's look at some example problems. Find the x-intercepts and the vertex of the parabolas. So notice we don't even care about up opens up versus down anymore. That was easy stuff. I don't care anymore. I think you know it by now. But the x-intercept for this, you look at this first one, hopefully you realize the x-intercepts are going to be at x equals negative 3 and negative 5, because it's the opposite of the values there. Now if you want to find the vertex, here's what you do. The x vertex is going to equal your two x-intercepts, so negative 3 plus negative 5, which is really just negative 3 minus 5, and then you divide it by 2. And that's going to give us negative 8 over 2, which is negative 4. Keep in mind, negative 4 is smack dab in the middle of negative 3 and negative 5, especially if you were to graph it on a number line. And that makes sense because that's what I would expect to happen. The vertex should be in the middle of my x-intercepts, always. And now if you want to find the y value, well, you just plug in negative 4 here. So y equals negative 4 plus 3 times negative 4 plus 5. And you're going to get negative 1 times positive 1. You're going to get negative 1 as your answer for the y. So in other words, the answer for the vertex is going to be at negative 4, comma negative 1. And there we go. There's our answer. Any questions on that one? Okay, then let's keep going. Number 2, same idea. Very first thing I'm going to say, I immediately see the x-intercepts. They're going to be at x equals positive 12 and at negative 2, because it's the opposite of these guys. So there's my x-intercepts. And again, if I want the x vertex, then I'm going to say it's 12 minus 2 divided by 2, because it's these numbers added together and then divide by 2. So 12 minus 2 is 10, divided by 2 you get 5. And then if you want the y value, well, you just got to plug in y here. It's going to be negative quantity 5 minus 12 times 5 plus 2. And so that will give us negative times 5 minus 12 is negative 7, times 5 plus 2 is positive 7. The double negative cancels out, and 7 times 7 is 49. So it looks like my vertex is going to be at 5, 49, and there's our answer. So if that makes sense, go ahead and try number 3 on your own. I'm going to give you a minute to do that, and then you can, if you're watching online, unpause the video and we'll see what we get. So I'm going to give you a minute to answer this. Go ahead. And time's up. So for this one, I'm going to say the x-intercepts are going to be at x equals negative 9 and negative 5. Hopefully you got that. And now the other thing I want to say is if we want to find the x vertex, then all I'm going to do is say the x vertex equals negative 9 minus 5, and then divided by 2. So negative 9 minus 5 is negative 14, divided by 2, we're going to get negative 7. And then if you want to find the y value, y equals 3 times negative 7 plus 9 times negative 7 plus 5. We're going to get 3 times 2 times negative 2. That's going to be 6 times negative 2, which is negative 12. It looks like my vertex is at -7 comma -12. Hopefully you got that. If not, then hopefully you see the correction. And then for the last one, number 4, again, go ahead, try that one on your own. And if you're watching the recording, unpause it when you're ready to see the solution. So go ahead. Okay, time's up. Let's see if you got the right answer. So first we got the x-intercepts at x equals -3 and +7. Okay. And then if we want to find the x-vertex, that's going to be at -3 plus 7 divided by 2. -3 plus 7 is 4, and 4 divided by 2 is just 2. So there's the x-vertex. And once again, if you want to find the y-vertex, you just got to plug in here. -2 times 2 plus 3 times 2 minus 7. And that's going to be -2 times 5 times -5. -2 times 5 is -10 times -5. That's going to be +50. So in other words, the vertex is going to be at 2 comma 50. And there we go. And that's it for today. So thank you all for joining me. We only have one lesson left, week 8. So I can't wait to see you all there. Thanks again for joining me this summer. And I hope you have a great rest of your Tuesday. I'll see you next week. Take care, and bye-bye.